Hi, I'm going to talk transform all architecture to the new one and how the CI and CD and new architecture actually works. So,
I think we have a little problem with the tone.
I don't understand.
We can't hear you. Now again, but
And now it's better?
now it's better. Yeah.
So we've started like dinosaurs in 90s and we are moving fast to the new stuff, basically. So the first step of digital transformation is to define a problem. We've defined that we had way too many applications, as you can see, doing the same thing or even the same name of applications, which is actually two. We have too many old and strange technologies used. And we have too much of strange architecture connecting, like we are using DigitalOcean, Heroku, AWS to Bahnhof data center and on-prem servers in all. We started to plan. We get familiar with business process, consolidate technologies, prepare proper infrastructure, and set up migration plan. For obvious reason, I will be focusing on the latter, these 2 points. So we basically removed Bahnhof, on-premise services, Heroku, DigitalOcean, and left with AWS only. Technological-wise, we've removed everything and rewrote all to Python, Postgres, and React. And also some AWS components if required, like SQS for queuing, DynamoDB, or Redis for cache. First step to look after when you're taking over from all the infrastructure is to see if RDSs are open publicly, if the SSH is open to the world, or some obvious security flaws, upgrade everything we can. And if there is no, there should be only strict connections between Google Docs, apps, RDSs. This is what Lucas said, that security needs to be responsible, and we have to only give this part of piece of what application is actually required to do. We've basically done microservice architecture, which is instead of monolith application, we've separated to the several small business logic separated components that work together and are easier to maintain. One team of developers can maintain one of these square or two, or depends on the needs, and then just deploy only one part of it instead every time deploying the whole thing. So the main principle of ours is as little maintenance as possible, as serverless as possible. So we do not have bare metal, we do not have EC2s, we are just using cloud, and as easy as possible. So, for example, we've come up to the situation when there are no developers left from company that wrote some app, and nobody knows how it works. So we, as DevOps, for migration, we have to know how the app works without developers. So, for example, we can go to AWS, check on which port application is using, and then check on server which port are listening to, and then take process PID, basically process ID, which it's easy from there, but we often didn't have SSH key for old EC2, so we just created AMI from it and recreated with new key. This is fun trick if you ever lost SSH. And then you just can go cat procs and PID /environ, and you have all and environmental starters from application, so it's easier to do. And also where the code lies in server. For example, if you have runtime. It also applies to Docker and Kubernetes and basically all Unix processes. And then we've created ECS service and Docker. We also used proxy farm pattern for static content for React apps or Vue apps, or basically front-end. We do not use CloudFront because we have Akamai and it is basically the same stuff. So we are just using Akamai, then going to the load balancer and ECS, and Amazon S3, which we store our websites, static websites. And for example, if business doesn't know if something is used or not, then you can probably should see connections to RDS or load balancers. And if there's zero, then the simple strategy, close traffic for a week, then see if someone was using it. If not, then create AMI and see if someone screams. Basically, my policy is to delete resources as much as possible, because often something is left over, and it's a very good and efficient way to save money. So this is our new infrastructure. A user is calling through Cloudflare, which is our DNS, to Akamai, which is our firewall, and the CDN, then to one of the three load balancers, which has also web application firewall enabled. User interface layer is just the front end. So this is the pattern I've shown you earlier with the proxy farm. It shows to the ECS and then to Amazon S3 to show static front-end website. Then it has BFF pattern, which is called backend for front-end. It's consolidating multiple APIs into one. It's a more advanced API gateway. And it also starts on ECS. It has S3 and it's connecting to the API. An API has one cluster with different service in it. For data store, we are using mostly Dynamo and RDSs. And for logging, we have Amazon Elastic Cache Service and Amazon CloudWatch, so we don't care, again, about scaling, reliability, anything. Basically, all SLA is on Amazon. This is one of our clusters, and here I can show our CD. So basically, we are using Bamboo instead of Jenkins from Atlassian. It's a really nice integration with Jira. It has automatic trigger. What it is doing is just building Docker image, then deploying here. Deploy looks like you just run Terraform with the new tag for Docker, and that's it. You don't need to update anything. You don't need to update pod. You don't care about ingress. You don't care about task is defined like this. So you have to define like environmental variables, how many CPUs do you want per pod, how many memory, which image to use, entry point command. Basically, that's it. To change that, you just go to locals and change these values, basically in Terraform. Everything is stored here in ECS, so we do not have to manage, we do not have to scale, we do not have problems like you try to solve, like where to store ingress, how to scale Kubernetes, updating agents, updating security resource, etc., or managing disk space. It's all handled by us. We have clusters, for example, I don't know. It has several services, and as you can see, this has two instances, for example. You can see the tasks running inside. If we go, for example, to one service, then we have logs for it, basically metrics already out of the box, auto scaling, which is also out of the box, and basically my life is easy thanks to that. What else? How it goes to internet? Basically, we have like target load balancer, which has these rules. Each load balancer has several routing rules. For example, if someone is carrier task, then it goes to proxy farm. But if it's API or SP or assets, then go to admin API. And admin API is just target group. As you can see, SCH Live admin API points to SCH Live admin API. That's it. Load balancer, ingress, everything done by a It's also serverless, so I do not care about EC2. In fact, we have like only 4 EC2s, and we are aiming to have 0 in 2 months or 1 month, basically. And yes, other thing that we've implemented is different storage classes for S3, like standard, intelligent tiering. Mostly we are using standard because intelligent tiering is not good for us because we have too many small objects. And we also use Glacier and DeepArchive for backups. And thanks to that, from January to August, we've saved for over 50% of cloud costs. So we have less man hours for maintaining stuff from DevOps side, smaller numbers of required teammates, and also it's cheaper and safer because on SLA are on AWS. And that's it. Thank you.